So after you've got a hold of all the different tools for trigonometry, you understand the associated angles, and you have the two main identities, which are the Pythagorean identity and the tan identity. So you can now slowly start to solve trigonometric equations. And I'm going to go through some of them, but it's important that you understand the basics. So if any part of what I'm saying is a bit confusing, go back to the previous videos linked with trigonometry and all the angles on the unit circle and so on. So I'm going to start off quite big here. And I have this equation in terms of tan. So I have tan squared x minus tan x minus 2 equals to 0. You actually don't have to use any of the identities or so. The trick in this question, which actually appears very often when you're dealing with functions, is that this is basically a quadratic in terms of tan. So you can, what we could do is like substitute, instead of u, we can write tan x, and that would just give us a nice way of rewriting this function. So instead of, this is tan squared x, which means it's going to be u squared, and then minus u minus 2 equals to 0. And there you go. It looks like a quadratic. Obviously, I'm not using x because x is our angle. And we can actually solve this quadratic equation. So I forgot to define this. This is x between 0 and 2 pi. So now that you have this quadratic equation, try to spot it from the beginning. As soon as you see something squared minus your tan or so, then you can solve it. So this will appear again in the video. And then you can solve this quadratic however way you want. If it's a non-calculator paper, obviously you should know how to factorize this, or if you've memorized the quadratic equation. I'm going to use factorization. This is going to factorize to u minus 2 and u plus 1, which means this is u equals to 2 and u equals to negative 1. I have a video on factorization and solving quadratics, so if you're confused, just go back to that. But now I need to bring my substitution in, so it's tan x equals to 2 and tan x equals to negative 1. And then I could solve it. So sometimes the solutions will be invalid, so sometimes, and we won't get in this case, but there are some questions that this will be the case. So I could take tan inverse of 2. I'll deal with this in a bit. Let me just do the first part. So this will be, if I just use a calculator for this, x will be approximately 1.11. This is the answer I'm going to write here, but I have the full decimal places with me on the side because I need to use it later on. So remember that when you have the unit circle, you have the which quadrant has the positive values, where tan here is positive, meaning that I won't only get one solution, I'll get two solutions. And I know I'll get two solutions because I'm within the full two circles. If it only says 0 to 180, then I will most probably get only one solution. So for positive, I need two solutions, and those two solutions lie in the first quadrant and the third quadrant, sorry. So first and second quadrant. This is automatically the first quadrant, and you can test it out using, well, this is 0, this is pi over 2, and this is approximately 1.5 something. So 1.1 is still here. So this is the first quadrant. To get the value in the second quadrant, you need to know the formula. So this is x1, and I could say x2 is equal to pi plus this value, but because you've approximated this already, make sure you use more decimal places when you're calculating this. So I've added more decimal places here, but my answer to 3 significant figures is this. So This is to 3 significant figures as well. So I have these two angles now, one in this quadrant, one in the other. Now when I'm coming here, tan is negative. So now I'm looking at the second quadrant and the fourth quadrant. But when I will try to solve this, I will solve it for the positive. I did mention in previous videos that you can solve it for a negative, but it's just easier to deal with the positive. So I'm going to take tan inverse of a positive 1, because that's going to give me the answer in the first quadrant, and then I could use this as a reference and then deal with the other quadrants. So x is going to give me pi over 4. Because if you write -1, the calculator is going to give you negative pi over 4, and then you'll have to convert it to a positive angle, and it's just a longer path to take. So this is the first quadrant, but I need it in the second and fourth quadrant. So second quadrant is going to be pi minus pi over 4, so that's going to give me 3 pi over 4, which is approximately, you can leave that as a fraction, but depending on the question. And then the fourth quadrant is going to be 2 pi minus pi over 4, which is 7 pi over 4. And again, I can approximate this, and I have 5.50. Again, that's the 3 significant figures. So I actually have 4 solutions. This is 1, 2, 3, 4. So I have 4 solutions here, and you can check. So do take the time to check. Substitute the first one in this function and check that this equation, and check that you actually get a 0. Check the other one, and so on. If you have a calculator, you can graph this, and then from 0 to 2 pi, you can check when is the intersection equal to 0. When does the graph intersect the x-axis at 0, and it should give you 4 points here. So it's just make sure your calculator is on radian mode for this to appear, and your calculator's window is set from 0 to 2 pi. So that's another way of solving it graphically.